Good morning. Welcome to the online session of design and analysis of algorithms. Students, this is the last topic in first unit of design and analysis of algorithm. So in this video lecture, let us discuss about the algorithm growth rate, the time complexity of an algorithm growth rate will be, how it will be, we will discuss in this online session. Now let us move to the session. So I already said that algorithm is a step-by-step procedure to perform a computational task. It is a step-by-step procedure to perform a computational task is known as an algorithm. To perform a step-by-step procedure, the efficiency of an algorithm is to be measured at some point of time. So the efficiency of an algorithm can be measured by using two factors or two methods, namely time complexity and space complexity. So time complexity in the sense the amount of time required for compiling or executing an algorithm is known as time complexity of an algorithm. Whereas space complexity is another methodology. Space complexity of an algorithm is nothing but the amount of storage or memory is really required for storing the algorithm is known as space complexity of an algorithm. So always we can conclude or say that the efficiency or the speed of an algorithm can be depends on time complexity and space complexity. So in time complexity, there are three types of time complexity: best case time complexity, worst case time complexity, average case time complexity. Best case time complexity in the sense, so the algorithm can take minimum number of steps for executing is known as best case time complexity. If an algorithm takes maximum number of steps for executing or compiling, it is called as a worst case time complexity. If an algorithm takes average number of steps for executing, the algorithm is known as average case time complexity. So while calculating the time complexity of an algorithm, there is a formula: time complexity equal to space complexity, time complexity equal to time complexity we can find out using the following formula. Time complexity equal to compile time and run time. So compile time, how many number of steps an algorithm can take, plus how many number of times the algorithm can do for running. So total compile time plus run time is considered as a time complexity of an algorithm. So here the complexity of an algorithm can be found in order of growth. In the order of growth, typically, the complexity of an algorithm can be placed in any one of the component listed over here. So the complexity can be found in any one of the form in such a way that sometimes the algorithm time complexity is constant. It is constant. There is no vary. Sometimes the algorithm time complexity is constant. Sometimes the algorithm complexity is logarithmic. It is logarithm. There is an improvement. And another one is linear, quadratic, cubic, exponential. These are different forms. The algorithm can be placed in any one of the form. So if you consider the order of growth of an algorithm, so it will start from constant and ends with a exponential. So this is considered as the order of growth of an algorithm. If you consider the first case is the first form is constant complexity. When we can say the algorithm complexity is constant, that means that if an algorithm time complexity is order of 1, big O of 1, that is called as a time complexity of an algorithm. Not only order of 1, it may be order of 1, order of 5, order of 10, or order of 100. Whatever it may be, all these values will be considered as a constant values. Constant values. So, in this case, this constant complexity will be applicable. When logarithmic complexity will be applicable, when an algorithm time complexity is order of log n, when the algorithm time complexity is order of log n, then we can say that the algorithm is in the form of a logarithmic complexity form. So in this case, the execution of an algorithm takes order of n steps to perform the operations of n operations in this one. And third one is linear complexity. Linear complexity in the sense, if an algorithm execution time is n order of an algorithm execution time is order of n, then we can say that it is comes under the linear complexity form. Next is quadratic complexity. Quadratic complexity in the sense, an algorithm time complexity is order of n square. Order of n square. Then only we can say that the algorithm time complexity will comes under the form of quadratic complexity. Next complexity is cubic complexity. Cubic in the sense, the power of an algorithm, the power of number of steps is very more. It imposes the complexity of the given algorithm is big O of n cube, n power 3. That shows it is a cubic. Next, last one is exponential component. Exponential complexity in the sense the algorithm time complexity is order of 2 power n or order of n factorial, basically factorial, that is nothing but iterative. If an algorithm will comes under iterative methodology, so in this case the exponential time complexity form will comes under this picture. So, students, there are typically 6 different algorithm time complexity order of growth we listed here. The first one is constant, second one is linear, and third one is second one is for constant, logarithmic, linear, quadratic, cubic, and exponential. So these are the order of growth of an algorithm. So there are two types of algorithms basically in our day-to-day life we will see. The first one is iterative algorithm and the second one is recursive algorithm. So what is iterative algorithm and what is recursive algorithm? What is the difference between these two algorithms? Let us discuss in this session. So iterative in the sense, the function repeatedly runs. A function repeatedly runs until the condition meets or false. In an algorithm, sometimes the condition met, sometimes the condition is false. If an algorithm of the function, if the function within an algorithm repeatedly runs until the condition met or false, it will comes under the concept of looping. Looping, it is called as a iterative function or iterative algorithm. When comes to the point of recursive algorithm, in this recursive algorithm, the function can call by itself. A function within an algorithm can call by itself is known as a recursive algorithm. This can be happened until the condition met. There is no false concept here. So until the condition is met, that means that the algorithm is can call the function by itself until the condition is true. So it integrates the branching structure, then only we can consider it is a recursive algorithm. While analyzing the algorithms using iterative and recursive, whenever we are analyzing the iterative algorithms or programs, we have to count the number of times the loop is executed. How many number of times the loop structure within the algorithm or program can executed, which can be treated as the analysis of iterative program. Whereas come to the recursive program or recursive algorithm, we use recursive equations. Recursive equations we use to write the function. So one of the recursive equation is f of n by 2. Function of n by 2 is the recursive equation. That is called the function can call by itself how many number of times that can be measured here. So here the difference between iterative and recursive is clearly defined in this session. So next is the order of growth rate of an algorithm time complexity. So if you consider the lower part, order of growth of some common functions, starting is order of 1. It will begins the growth or the order of growth rate of an algorithm begins from order of 1 and ends with the order of 2 power n. It seems to be the order of growth of an algorithm can be placed in any one of the form like constant form, linear form, logarithmic form, exponential form, quadratic form, or some other forms, whatever applicable. So the order of growth of common functions will be listed here. It will begins order of 1, then next move to order of log n. Order of log n is smaller than order of n. Order of n is smaller than order of n into log n. Order of n into log n is smaller than order of n square, and order of n square is smaller than order of n cube. Order of n cube is smaller than order of 2 power n. So this is the order of growth of algorithm complexity. So here the comparison among different algorithm complexity forms will be listed over here. This is the constant form. So the form is order of 1. That means that an algorithm is the algorithm time complexity is always constant. In some cases, in this case, the time complexity of an algorithm will be considered as a constant form time complexity. So here consider the value is n. If the value of n is changed, the constant, the algorithm growth rate will not be changed. It will be always constant. Then only we can consider it is a constant algorithm time complexity. Logarithmic order of n into log n. Substitute the value of n here, and the algorithm growth rate will be here. We have to see 1, 1, 2, 3, 4, 5, 6. Next one is linear form. Linear form in the sense the order of growth of an algorithm, it seems to be the algorithm size is doubled in each and every step. Best example is hash table. In a hash table, if you want to increase the size of the table, sometimes the array size will be doubled. Here the array size is 1, array size is 2, array size is 4, array size is 8, 16, 32, 64. The order of array size is doubled in some cases. In this case, we can conclude that the algorithm time complexity is order of n, that is linear. Next, order of n into log n. This will comes under the quadratic. Order of n square is quadratic. Order of n cube is cubic. And order of 2 power n is exponential. So this is the lowest time complexity, and this is the highest time complexity. In this way, we can measure the time complexity of an algorithm. So this is the last topic in Unit 1, Design and Analysis of Algorithm. Hope you all are understood the concepts and the videos what are posted earlier. My videos is enough for you for preparing university examinations as well as competitive examinations. Hope you are doing well. Thank you. Thank you so much.